Picture this. It's 2023 and a rancher in Montana is trying to pull a loaded cattle trailer up a muddy 15-degree incline. His brand new F-250 with 475 horsepower is spinning tires, going nowhere. His neighbor rolls up in a 1982 GMC with a 230 cubic inch straight six, making a pathetic 140 horsepower. He hooks up, drops it into first gear, and crawls up that hill like it's a joke. The modern truck driver is left wondering what just happened. The answer involves a gearbox, GM, designed in 1966, that understood physics better than any engineer working today. The malaise-era truck crisis. Let's rewind to the late 70s and early 80s. The automotive world was in absolute shambles. The EPA had strangled engines to the point where full-size trucks were making less power than modern lawn tractors. We're talking about the dark ages of American automotive performance. Compression ratios had been slashed from 11:1 down to 8:1. Camshafts were so mild they might as well have been straight rods. Carburetors were choked with emissions equipment that seemed designed specifically to make engines run worse. GM's truck lineup was particularly pathetic. The base engine in a 1980 C10 was a 250 cubic inch inline six, making 130 horsepower. From 4.1 liters. That's roughly 32 horsepower per liter, which is what you'd expect from a tractor, not a truck. The optional small block V8 wasn't much better, making around 165 horsepower from 305 cubic inches. These weren't performance figures, these were cries for help. But here's the thing nobody talks about. Truck buyers in the 70s and 80s didn't care about horsepower. They needed to pull trailers, haul loads, climb mountain passes with 5 tons of equipment. They needed torque, and more importantly, they needed that torque multiplied through the drivetrain in ways that made their weak engines feel strong. Horsepower is what you brag about at car shows. Torque is what gets work done. And GM was about to prove that gearing matters more than either. Detroit's solution to the power crisis was typically backwards. Ford started offering bigger engines, thinking displacement would solve everything. Dodge tried different carburetor setups and ignition systems, just rearranging deck chairs on the Titanic. GM did something different. They realized that if they couldn't make more power at the engine, they'd multiply what little power they had through the transmission. It was brilliant in its simplicity. It was also something that modern truck engineers seem to have completely forgotten. The typical response was to add more gears. 4-speed automatics, 5-speed automatics, eventually the 6-speed and 8-speed units we have today. More gears meant more opportunities to keep the engine in its power band, right? Wrong. More gears meant more complexity, more weight, more things to break. And ironically, less actual pulling power at the wheels where it mattered. GM had figured this out in 1966, but everyone else was too busy adding complexity to notice. The problem nobody was solving. Here's what makes a truck useful: low-end grunt. The ability to start moving a heavy load from a dead stop. This requires torque, lots of it, delivered right now. Not after the turbo spools up, or the transmission downshifts, or the computer decides you really mean it this time. In the 70s, with emission-strangle engines making minimal torque, this was a massive problem. The engineering challenge is actually pretty simple when you break it down. An engine makes a certain amount of torque at the crankshaft. Let's say our pathetic 130 horsepower straight six makes 210 pound-feet of torque. That's not much. A modern Civic makes more. To make that torque useful for pulling a loaded trailer, you need to multiply it through the drivetrain. The transmission's first gear is your first opportunity for multiplication. Then the transfer case if you have four-wheel drive. Then the differential gears. By the time torque reaches the wheels, it should be dramatically higher than what the engine produced. Most manufacturers were focused on highway gearing. They wanted trucks that could cruise at 70 miles per hour without the engine screaming. This meant taller gears, lower numerical ratios, less multiplication. Great for fuel economy and comfortable cruising. Terrible for actually working. A truck with 3.08 to 1 gears in the differential and 2.5 to 1 first gear in the transmission gave you about 7.7 to 1 overall first gear ratio. Adequate for moving the truck empty, pathetic for pulling anything heavy. Ford's solution was the E40D transmission, which had a 3.98 to 1 first gear. better, but paired with 3.08 rear gears, you still only got about 12-1 overall. Dodge was running similar numbers with their A727 torque flight. A robust transmission, but not particularly aggressive in first gear. Everyone was building trucks for soccer moms who needed to tow a boat once a year, not for ranchers who pulled loaded trailers through mud daily. GM looked at this problem and asked a different question. What if we just made first gear absurdly low? What if we created a gear so low that even our pathetic emission-strangled engines could pull anything? What if we stopped trying to make the engine better and just multiplied whatever torque we had more effectively? This line of thinking led to the Muncie S M465, and it would embarrass every modern truck transmission for the next 50 years. The pushback was immediate. Engineers said nobody would want a truck with such low gearing. Marketing said customers would complain about having to shift too much. Dealers said it would be too hard to explain. Everyone had an opinion about why this was a bad idea. Nobody actually tested whether it would work. That's the thing about innovation. The people who know why something won't work are rarely the people who make it work anyway. The Muncie S M465. The Muncie 4-speed started life as a heavy-duty manual transmission for serious truck applications. This wasn't a passenger car gearbox adapted for truck duty. This was purpose-built for abuse. Cast iron case, massive gears, bearing size for punishment. The synchronizers were optional on first gear because GM knew that in many applications, this transmission would be paired with a granny gear so low that you'd never use the synchro anyway. You'd just grind it in there because by the time you needed first gear, you weren't moving. The designation S M465 stood for Saginaw Muncie 4-speed, 465 pound-feet of torque capacity. That rating was conservative. These things regularly handled much more, especially in the heavy-duty Chevrolet and GM medium-duty trucks, where they were standard equipment. The case was a single casting, no aluminum, no cost-cutting measures. This transmission weighed about 175 pounds, which by modern standards is absurd. A modern 10-speed automatic in an F-150 weighs about 250 pounds and can't handle the same abuse. Here's where GM did something brilliant. They offered this transmission with multiple first gear ratios. The standard version had a 6.55 to 1 first gear. 6.55. Let that sink in for a moment. Modern truck transmissions typically have first gears around 3.5 to 1, maybe 4 to 1 if you're lucky. They literally doubled the torque multiplication in first gear compared to what everyone else was doing. But wait, it gets better. For guys who really needed pulling power, GM offered a close ratio second and third gear option that pushed first gear even lower. Some applications got a 7.05 to 1 first gear. There were even industrial applications running 7.5 to 1. At that point, you're not driving in first gear, you're crawling. Top speed in first gear with a 7 to 1 ratio and 4.10 rear gears was about 4 miles per hour at 2,000 RPM. You could walk faster, but you could also pull a house off its foundation. The rest of the gear stack was interesting too. Second gear was 3.58 to 1 in the wide ratio version. Third was 1.7 to 1. Fourth was direct drive at 1 to 1. Notice the massive gap between first and second gear. That's by design. First gear wasn't for driving, it was for pulling, for crawling, for situations where you needed maximum torque and zero speed. Once you got moving, you'd skip right to third in most situations. Second was there if you needed it, but the real magic happened at the extremes of the gear set. The granny gear secret. Let's talk about the physics that made this work, because this is where GM's engineers showed they actually understood what a work truck needed. Torque multiplication through gearing is simple math, but the implications are profound. Take that weak 250 cubic inch straight 6, making 210 pound-feet of torque. Pathetic, right? Now multiply it by 6.5 of 5 through first gear. That gives you 1,376 pound-feet at the transmission output shaft. Already impressive, but we're not done. That torque now goes through the transfer case, if equipped. A typical NP205 transfer case in low range gives you another 2 to 1 multiplication. Now, we're at 2,752 pound-feet. Still not done. That torque hits the differential, where even mild 4.10 to 1 gears multiply it further. Final torque at the wheels? 11,283 pound-feet. from an engine making 210 pound-feet at the crank. That's 53 times multiplication. Let that sink in for a moment. A 1980 GM truck with a 130 horsepower engine could put 11,000 pound-feet of torque to the ground. A modern F250 with 475 horsepower and a 10-speed automatic, even in 4 low with the deepest gearing, makes about 8,000 pound-feet at the wheels. The old truck, with less than a third of the horsepower, puts 38% more torque to the ground. This is why horsepower numbers are meaningless for actual work. The beauty of the SM465's design was its simplicity. There was no computer controlling shift points, no torque converter, slipping and wasting energy, no clutch packs wearing out. You had a clutch pedal, a gear lever, and your own right foot. If you needed maximum pulling power, you put it in first. If you needed to move faster, you shifted. The transmission didn't second guess you. It didn't have limp mode. It didn't require a software update. It just did what you told it to do. Modern truck engineers have completely lost this plot. They've become obsessed with gear count, as if more gears automatically means better performance. Ford's 10-speed has first gear ratios around 4.7 to 1. GM's current 10-speed is 4.56 to 1. These are better than the 5 or 6 speeds that came before them, but they're nowhere near what the SM465 offered in 1966. Modern engineers will tell you that they need those taller first gears to allow for more gears total, to maximize fuel economy, to meet EPA requirements. All true, all irrelevant if you actually need to pull something heavy. The granny gear also solved another problem that modern trucks struggle with: control. When you're backing a trailer into a tight spot, or positioning a piece of equipment precisely, or crawling down a steep incline, you need fine control at very low speeds. Modern trucks with tall first gears and touchy throttles are terrible at this. You're either going too fast, or you're riding the clutch or slipping the torque constantly. The SM465's ultra-low first gear meant you could idle along at 1 mile per hour with perfect control. No throttle needed, just clutch engagement. The engineering principle at work here is mechanical advantage, the same principle that makes a long lever more effective than a short one. The SM465's first gear was a very long lever. You traded speed for force, and in a work truck, that's exactly what you want. You're not racing, you're working. Speed doesn't matter when you're pulling a stuck truck out of mud or moving a loaded gooseneck up a mountain pass. What matters is having enough force at the wheels to overcome resistance. The SM465 gave you that force in abundance. Real-world domination. The stories from actual users of these transmissions read like tall tales, except they're all true. Ranchers in Wyoming pulling loaded cattle trailers through snowdrifts. Construction workers in Colorado moving equipment to job sites at 10,000 feet elevation. Loggers in the Pacific Northwest hauling massive loads down logging roads that barely qualified as roads. The SM465 made all of this possible with engines that on paper had no business doing any of it. One particularly memorable account comes from a rancher in Montana who ran a 1983 Chevy K30 with a 292 inline 6 and the SM465. This truck made maybe 150 horsepower on a good day. He regularly pulled a 30-foot gooseneck trailer loaded with cattle, total weight around 18,000 pounds, through mud, snow, and up steep grades. His neighbor had a brand new Ford F350 with twice the horsepower and an automatic transmission. The Ford couldn't do what the old Chevy did. Not even close. The difference came down to control and torque multiplication. The Ford would spin tires trying to get moving with that heavy load. Too much power hitting the ground too quickly. Overwhelming traction. The driver would have to modulate the throttle carefully, slipping the torquey converter, heating up the transmission. The old Chevy, drop it in first, let the clutch out, idle away. The engine barely worked. The transmission did all the work, multiplying that meager torque into earth-moving force at the wheels. The Ford driver would watch in disbelief as the ancient Chevy outpulled his modern super truck. Construction sites were another proving ground. There's a documented case of a 1979 GMC with an SM465 being used to pull a stuck excavator out of mud. The excavator weighed about 30,000 pounds and was buried to the axles. Multiple modern trucks had tried and failed, including a Dodge with a Cummins diesel. The old GMC, with its 250 straight 6 and granny gear, backed up, hooked a chain, and pulled the excavator out like it was nothing. The operator said he never got above idle in first gear. Just let the clutch out and let physics do the work. Off-road enthusiasts discovered these transmissions in the 90s and 2000s. Rock crawlers realized that the SM465's low first gear, combined with the right transfer case and differential gearing, could create crawl ratios that modern trucks couldn't match. A properly geared rig with an SM465 could achieve crawl ratios over 100 to 1. This means the engine crankshaft turns 100 times for every rotation of the wheels. At idle, you're moving about as fast as a snail, with perfect control and enough torque to climb vertical rock faces. The Jeep community got involved too. The SM465 was slightly too large for most Jeep applications, but the SM420, its smaller brother with similar gear ratios, became highly sought after. Guys were pulling these transmissions out of junked S10 pickups and installing them in CJs and Wranglers. Why? Well, because even Jeep's purpose-built off-road transmissions didn't have gearing as aggressive as what GM had created for work trucks 3 decades earlier. The math that embarrassed Detroit. Let's do some math that shows just how badly modern trucks have lost the plot. Take a 2023 Ford F-250 with the 7.3-liter V8. This engine makes 430 horsepower and 475 pound-feet of torque. Impressive numbers. It's paired with a 10-speed automatic transmission with a 4.69 6-to-1 first gear. The rear axle has 3.7 3-to-1 gearing. The transfer case in 4-low gives 2.7 to 1 multiplication. Total torque at the wheels in the lowest possible gear. Let's calculate it. 475 pound-feet times 4.70 times 3.73 times 2.7 equals 22,479 pound-feet. That sounds massive, right? It is. It's also misleading because modern automatics lose about 15% of torque to slippage in the torque converter under load. So, real world, you're getting about 19,107 pound-feet. Still, impressive. Now, let's look at our pathetic 1982 Chevy with the 292 inline-6, making 140 horsepower and 230 pound-feet of torque. SM465 with 6.55 first gear. NP205 transfer case with 2.0, 1 low range. 4.56 rear gearing because this truck was optioned for work, not highway cruising. Total torque at the wheels, 230 times 6.55 times 2.0, 1 times 4.56 equals 13,773 pound-feet. No torque converter losses because this is a manual. That's with an engine making less than half the torque of the modern Ford. Now here's where it gets interesting. That modern Ford weighs 7,200 pounds. The old Chevy weighs 4,800 pounds. Torque to weight ratio. The modern Ford puts 2.65 pound-feet to the ground per pound of vehicle weight. The old Chevy, 2.87. The old truck actually has a better torque-to-weight ratio despite having a third of the horsepower. But wait, there's more. The modern automatic has to go through all its fancy programming to figure out what gear to be in. It has to wait for the torque converter to lock up. It has to manage clutch pack pressures. All of this takes time. The SM465, you put it in first gear and go. No lag, no waiting, no computer intervention. The response is immediate and predictable. The fuel economy math is interesting too. That modern Ford gets about 14 miles per gallon in real-world heavy towing. The old Chevy got about 12. You're spending 33% more on fuel, gaining 47% more horsepower, and getting worse real-world pulling performance in challenging situations. The math doesn't lie. Somewhere along the way, we traded actual capability for spec sheet numbers that look good in marketing materials. Modern truck buyers don't realize they're being sold a bill of goods. The manufacturers tell them they need 450 horsepower to tow 12,000 pounds. It's nonsense. You need torque multiplication at the wheels, which is a function of gearing, not peak horsepower. The SM465 proved this conclusively 50 years ago. A weak engine with good gearing will outwork a strong engine with poor gearing every single time in the real world. Why GM killed their own success. So if the SM465 was so good, why did it disappear? The answer is depressingly typical of Detroit short-sightedness. Marketing research in the mid-80s showed that truck buyers increasingly wanted automatic transmissions. Manuals were seen as old-fashioned, harder to drive, less comfortable for daily use. The fact that manuals were more capable for actual work didn't matter. Buyers wanted automatics, so manufacturers gave them automatics. The second problem was the chicken tax and changing truck demographics. In the 80s, trucks stopped being purely work vehicles and started becoming lifestyle vehicles. Suburban dads wanted trucks that drove like cars. They didn't need granny gears, they needed cup holders and air conditioning. M's marketing department realized they could sell more trucks by making them more car-like, even if that made them less truck-like. The third issue was fuel economy regulations. CAFE standards started applying to light trucks, and suddenly manufacturers cared about MPG. A granny gear that allowed you to pull a house was terrible for EPA testing. It meant the overall gearing had to be lower numerically, which meant worse highway fuel economy. Never mind that nobody actually used first gear on the highway. The EPA test cycle didn't care about real-world usage. By the mid-90s, the SM465 was relegated to heavy-duty applications, medium-duty trucks, and special order options. GM pushed their 4-speed automatics hard, claiming they were better for towing. They weren't, but they were better for EPA numbers and easier for soccer moms to drive. The last consumer-oriented truck to offer the SM465 was probably a 1991 or 92 CK series. After that, if you wanted one, you had to order a commercial chassis. The final nail in the coffin was electronic control. Modern trucks are completely computer-controlled. The engine, transmission, transfer case, differential, all talking to each other constantly. A purely mechanical transmission like the SM465 doesn't fit into this ecosystem. There's no data bus connection, no way to integrate it with traction control or stability control or any of the other nanny systems modern trucks require. Rather than engineer around this, manufacturers just eliminated manual transmissions entirely. Modern trucks can't do this. Here's what modern truck owners discover when they actually try to work their trucks hard. They don't work as well as the marketing promised. All that horsepower doesn't help when you're trying to back a trailer up a steep boat ramp with a crosswind. The automatic transmission hunts between gears constantly. The throttle-by-wire system is too sensitive, too touchy. There's lag between when you press the pedal and when the engine responds. Modern trucks are optimized for acceleration runs and EPA testing, not for the precise low-speed control that actual work requires. Rock crawling is where this becomes most obvious. Modern trucks, even though specifically marketed as off-road machines, have crawl ratios in the 40s or 50s to 1. A properly configured old GM truck with an SM465 can achieve 120 to 1. This means the modern truck has to slip the clutch in its automatic constantly to move slowly enough. The torque converter heats up, the transmission fluid gets hot, and eventually you're in limp mode. The old truck just idles along in first gear, perfectly happy, transmission is staying cool. Towing is another area where the old gearboxes shine. Modern trucks with tall first gears struggle to start moving with heavy loads on inclines. The automatic transmission has to use second gear, which means the torque converter is slipping significantly, generating heat. The engine has to rev higher, burning more fuel. The old SM465 equipped truck just drops into first, lets the clutch out, and moves. No drama, no heat, no problem. There's also the question of reliability and repairability. Modern 10-speed automatics are complicated nightmares of valve bodies, solenoids, and computers. When they break, and they do break, you're looking at thousands of dollars in repair costs. The SM465, it's a box full of gears and shafts. A competent mechanic can rebuild one in an afternoon with basic tools. Parts are still available because these transmissions were used in so many applications for so long. The control aspect cannot be overstated. When you're maneuvering a trailer into a tight spot, you need predictable, linear response. Modern automatics with their torque converters and programming give you anything but linear response. There's always a slight lag, always a moment where the transmission is deciding what to do. With the SM465, what you do with your right foot and left foot is exactly what happens at the wheels. No interpretation, no lag, no computer second-guessing you. The aftermarket resurrection. The off-road and rock-crawling communities never forgot about the SM465. As modern trucks became more computerized and less capable of serious low-speed work, enthusiasts started swapping these old transmissions into everything. You'll find SM465s in vintage Broncos, old Jeeps, Toyota Land Cruisers, even some custom rock-crawling buggies. Why? Because nothing modern comes close for pure mechanical torque multiplication. Advanced Adapters and other companies make adapter kits to mate the SM465 to almost any engine and transfer case combination. You can bolt one behind a Cummins diesel, a Ford V8, even a Toyota inline-6. The transmission doesn't care what's making the power. It just multiplies whatever torque you give it. This versatility has kept demand strong for good used units. The market for clean SM465s has gotten surprisingly hot. A transmission that you could pull from a junkyard for $50 in 2000 now costs $500 to $1,000 for a good core. Rebuilt units with the deep granny gear go for $1,500 to $2,000. That's for a transmission design from 1966. The demand exists because modern options can't replicate what this old gearbox does. Some companies are even making brand new SM465s. Not remanufacturing old ones, actually casting new cases and gears. The demand is there from industrial users, off-roaders, and people building serious work trucks who know that a 50-year-old transmission design is superior to anything modern for their specific application. That should tell you everything about where truck engineering has gone wrong. The bigger lesson. The story of the SM465 is really a story about the difference between engineering for specifications and engineering for purpose. Modern trucks are engineered to hit certain numbers in standardized tests. 0 to 60 times, fuel economy ratings, horsepower figures that look good in advertisements. The SM465 was engineered for purpose, to multiply torque effectively, to give weak engines real pulling power, to provide control at low speeds. This is a lesson that modern engineers seem to have forgotten or actively rejected. More gears aren't better if they're all tall gears. More horsepower isn't better if you can't put it to the ground effectively. More technology isn't better if it gets in the way of doing work. Sometimes the simple mechanical old-school solution is actually the superior solution, not in spite of its simplicity, but because of it. The SM465 teaches us that marketing-driven engineering leads to products that look good on paper, but underperform in reality. GM stumbled into brilliance with this transmission. They created something that solved real problems for real users, and then they abandoned it because it didn't fit the narrative of progress and advancement that marketing departments needed to sell trucks to suburbanites. There's something almost poetic about a gearbox from 1966. Embarrassing transmissions from 2023. It's proof that innovation isn't always about adding more. Sometimes it's about understanding the fundamentals so well that you can create something simple that outperforms complex alternatives. The SM465 understood that in a work truck, torque multiplication through gearing matters more than peak horsepower. Modern trucks have forgotten this, to their detriment. Every time someone swaps an SM465 into a modern truck project, they're making a statement. They're saying that old doesn't mean obsolete. They're saying that simple can be better than complex. They're saying that sometimes the engineers from 50 years ago understood the problem better than the engineers today. And you know what? They're right.